Now we have Mr. Rahul, Mr. Amitakhya, and Mr. Sriram from Disney and Hotstar, and their topic will be the developer experience story. I would like to call them up on stage.
So, hello everyone. First of all, a very warm welcome to everyone who has been part of this journey and organizing this QAI STC conference 2021. And here we come up with the developer experience story. Myself, Amitakhya, uh, pre- and my co-presenter Sriram Sridhar and Rahul Rathi. Unfortunately, Rahul could not make it out today over here because of some of his personal reasons. Okay, let me start off. So before we begin, let me start with what motivated us to do this. We conducted multiple surveys across different teams within the organization and interviewed multiple other developers to understand their current workflow and the gaps that exist and which make them less productive or consume more time in doing the same repetitive things. Uh, we got the data, analyze those data, and then start putting those data into different buckets, into actionable items, so that we can act upon it and help them be better at help them be better with their productivity. So this is where the journey has begun for us. The next thing is about the common problem statements. So after we gathered the data, we could see that the main problem statements revolved around these four primary categories, which revolves around, let me take one by one at a time. The first one is the API contract management. So at Hotstar, we follow microservice architecture like many other companies do follow nowadays. And contracts becomes the backbone to each and every integration for a microservice architecture. And with new features coming in place, the implementations keeps on changing along with the contracts. And having both integrated at the same time, like the contract and the code implementation should act similar to the contract. It was hard to maintain, and if the contracts are not maintained properly, we all know that we face problems and failures during the later phase of the integration testing. So this was one of the primary things that the developers faced, uh, uh, that hampered the productivity of a developer. And the next part is the unstable lower environment. Like I have already mentioned that we follow the microservice architecture. So in case of microservice architecture, you being a service owner will be somehow dependent on some of the other services. And the lower environments of your dependent services need not be always stable, because these are lower environments and the developers keep to push their test code, deploy it, and due to their instability, it always hampers your productivity in some or the other ways. And at the same time, it also reflects in the flakiness of your test cases. If you're trying to test a service under the test, but if it is dependent on multiple other services and they are not stable in their lower environment, your test cases will fail eventually. So this is one of the problem statements that we could figure it out. The third part is the test data service. Oh, sorry, the test data part. Because without a golden set of test data, your test cases are incomplete. We have seen it multiple times that we have automated a test case which do exist and ran successfully before a production release, but we missed certain test data combinations, and which led the way for bugs in production or in the upper environments. And in Hotstar, we have multiple subscription type and advanced features like Dolby, 4K, and different content categories. So each of them actually acts as a unique test data requirement which cannot be skipped before release, before making any release. So this is the test data part. And the fourth, the last but not the least, is the test automation. Because we are divided into different teams, what usually happens is every team uses their own type of automation framework. And if you use if your own automation framework according to your convenience, it lacks the standardization, and there is a lot of repetitive boilerplate work that needs to be done each and every time you try to add an API to it. This eventually makes the release cycle a bit slower than expected. Coming to the solution part of these four problem statements, like before I jump into the solution, I would like to go through the current workflow which which exist in the system. So in the right hand side, you can see a diagram where we have the developer repo, where the product owner or the typically a product manager comes with a new feature requirement, and a developer cuts a feature branch, develops the feature, writes their unit test cases, and then if everything is green, it goes and merges to a development branch. At the same time, in parallel, we have the automation repo where the test engineers add the integration test case, gets it reviewed by the test lead, merge it to the master branch. And once these two things are done, we execute the automation test case in any of the lower environment. And if everything looks good, we are good for the release. So this is how the current workflow looks like, a typical workflow. Coming to the next part of the solution. So we discussed about 4 problems, and we'll take one problem at a time. The first one is the API contract management. So in order to address this, we implemented the Open API specification for all the service repository within the service repository itself, and build tools on top of Open API with an integrated ecosystem connecting each tool with the other in some or the other way, which we'll be discussing during the last phase of this demo. Why did we use Open API? This is a very basic question that would come, because that is already a standard way that exists in the market, and we did not want to reinvent the wheel. Apart from that, it also has some great capabilities of generating mocks or test on top of it. And Open API also has the integrations with other tools like Postman and Swagger, which are commonly used tools for all the developers. So after this change, this is how the service repo would look like. So you have a service repo, you have a source code where all your implemented the developer code will reside into, and we have another directory called the spec folder. Inside this spec folder, we have different YAML files, that is the Open API YAML files defining the structure of all the APIs within this repo itself. So any service, any dependent service who comes and wants the implementation of any API, they would not go to this source code. They will just come to the Open API implementation and check how the API has been implemented. Coming to the next problem statement. The next problem statement was unstable lower environment, and this is how we tried to address. We named it as test in isolation. And let's take a typical example of test in isolation. Or the unstable environment. Towards the left-hand side of the diagram, as you can see, we have the automation test, and which is getting triggered to any service under test. And as this is a microservice architecture, this is highly dependent that your service, the service under test, is dependent on any of multiple other downstream services like service A, B, and C that you can see over here. And it is very likely that since these are lower environments, that one of these services will be unstable. This eventually results in test flakiness or failures for your automation test cases in service under test, and you will have to rerun your test case, which slows down the release process. And this is quite often with the lower environment tests and the test cases that we execute. So this is how we try to address over here. Towards the right side, you can see we have replaced all the 3 services, service A, B, and C, with the mock server. And since mock server is not used by any developers for any testing purpose, this is quite stable. And the automation test case that we execute, it's not flaky, and the release cycle is much faster than we had seen earlier. But what's new over here? Because mock server is something everybody uses in their day-to-day life. The new over here is, in the last slide, I have spoke about mandating Open API. So in order to spin up a mock server, you don't need to write any piece of code or something. From the contract itself, the mock server is smart enough to generate the mocks for you, so that there is no extra effort of generating the mocks. So it just takes minutes or seconds to spin up a mock server and host it. So this is something new about. Okay. So let's talk about what all are the capabilities that we have in a mock server. So this mock server that we developed has support for different protocols like HTTP, gRPC. It also have conditional mocking, where you can define conditions, and based on those conditions, you can get dynamic mock. For example, you can define that if the header value, a key of or header is equal to some value, then instead of getting me a default response, get me this response. Or you can override the response codes and all those things. So this is the capability of mocking dynamically. The next is hard to reproduce scenarios like latencies and failure conditions. Like as an application developer, you'd always like to check how your application behaves in case your dependent services are very latent or not reacting as expected, like latency scenarios or taking too much long time. It becomes very easy with a mock server to test those scenarios so that you build a more robust system. And the failure cases like 4xx or 5xx cases where like how does your application handle those scenarios. Apart from that, this mock server also has a capability of proxy support, usually for a client engineer who needs mock server along with proxy, so that they are able to proxy certain calls from the mock server itself. The last part is the variants of the mock server. This is a pretty important part over here, where we have two different variants of mock server. One is the CLI variant, where we have already integrated with Brew. Why Brew? Because Brew is one of the most simplest way to install and upgrade the CLI. The CLI that we develop. And the second part is the hosted variant. So in the last slide that we spoke about is the automation, replacing service A, B, and C with a mock server. So this is one typical use case of having a hosted variant, because for a automation test case, you need a hosted variant of this mock server. So this mock server can be used in two different ways. So let me come to the diagram over here, where we can see a service provider and service consumer and how does the workflow looks like. So a service provider and a consumer comes into a contract, writes it down in the Open API specification. Now the service provider, which typically can be a backend engineer, and a service consumer you can think it to be a front-end engineer. The service provider will go ahead and share the specs with all its dependent services so that they are unblocked, and they can launch their mock server with their CLI and test how the mocks look like, if there are any gaps or you need to change the contract even before developing it. At the same time, the service consumer gets the spec, launches their own mock server in their local system, and develops the feature parallelly. So now both the service provider and the consumer can work independently without having any dependencies. So once things are ready and in place, we can directly go ahead with the integration testing over here. So what have we achieved with all these mock server in place? So we were actually able to test the contract even before developing, even before writing a single line of code, we are able to test the contract. The next over here is we can develop much faster, because now the development is parallel. We are not dependent on any other services. So it's quite faster. We are able to test it locally with more conditions unlocked. Like I have already said, that we have latency scenarios, we have failure cases, etc. And the environment flakiness, the major issue is resolved, because you're not dependent on any other services. You can spin up your own mock server locally. So you are completely eradicating this environment flakiness issue for you. Okay, so the next part is around the standardization of the automation test case, because I have already spoken that everybody uses their own automation framework, so it becomes pretty difficult for everyone to maintain a standard way of writing the test case. So we wanted to maintain one standard way, so that every engineer in the organization speaks one common language in terms of how to write a test case. So what we did over here, we tried to decouple the like in Hotstar, we follow BDD way of writing test case. So in BDD we have feature files. So what happens with the feature files? We want to decouple the feature file with the execution layer. So we developed a service which will take care of the execution, and writing a test case, it's much more easier with that. And we developed this service in account of, we kept this in mind that we need to have one single place, so that every utilities that we build, like DB utilities or any common utilities, comes into one place and not scattered around different automation frameworks, having redundant work getting done. And also this also helps to have one single one single report for every type of automation, and there is a standardization across everything over there, and we push metrics to influx for showing it up to Grafana dashboards and everything. So the test as a service actually holds capable of all those things. Apart from this, because now we have standardized the way of writing test case, now we in the mock server CLI itself we have developed the capability of generating some initial set of test cases from the OpenAPI specs that we have already generated in the previous slide. So if you have the OpenAPI slide, the initial set of test cases are automatically generated for you, and all you need to do is deep dive and write some deeper integration test case, which you'll anyway have to do it. To make the execution even more smooth and easier for our developers, what we try to do over here is we developed an IntelliJ plugin to run these feature files locally for your use case. So if you can see the top diagram, this is how the workflow will look like. As a user, you write the OpenAPI specification, and once you have the OpenAPI specification, you can auto-generate the test case. You don't need to write the initial phase of test cases. That is automatically getting generated from the specifications. And after that, you can add deeper integration test cases like a complete flow diagram, like you call API 1, after that you go to API 2, all those deeper integration test cases, and then create a pipeline out of it. In our case, this is a GoCD CI/CD tool that we use. It can be anything like Jenkins or Harness. Uh, and let the service take care of the execution, and our service will take care of the execution, push the report, and do all the post execution task for that. And if you can look at the lower part of the presentation, we have the service repo at the middle. So towards the left of the service repo, this is how the service repo would look like. You have the source code and one more directory called the test. So what is this test directory? This will have all the feature files like feature 1.feature, feature 2.feature, and all those things, different kinds of feature of the APIs that are already implemented in the source code. So towards the right hand side of this service repo, we have GoCD trigger. So GoCD is a CI/CD tool that we use. It can anyway be replaced with Jenkins or any other tools, which will trigger the test cases to here we have written it endgame, because internally we call test as a service as endgame at Hotstar, and the endgame will take care of the complete execution. And in test as a service itself, we have common helpers like test data service integration, DB utils, property helpers, and all the other things which the utilities that is needed for an execution. And after the execution is complete, we push the reports to S3, we push Slack notifications and report analyzer, which is we are working upon this part, and push the matrices to influx for our Grafana dashboard to show up. So this is how the complete architecture looks for our test as a service. Next, I will pass it to you, Sriram, to take upon the next set of solutions, which is about the test data service.
Sure. Thanks, Amit. So, can we get the next slide, please? Yeah.
Yeah.
So, S data service is more like a standalone service, which basically generates and aggregates the data from all other services. So, since we are in a microservice architecture, right, your microservice will be dependent on the data which are generated by other microservices, right? So, test data will be a major concern when you are running your test cases. So, we are the service, meaning the test data service is the consolidator, which basically generates and aggregates the data. And we serve to multiple stakeholders, including automation suits as well. The test data can also be used in multiple manual scenarios, and it can be used in feature development as well. So let's say the examples of the test data will be like more of different types of subscriptions, different types of users, different types of content, as Amit said, let's say Dolby or 4K content, and different type of payment information, let's say credit cards or debit cards or 3DS tokens to basically validate the payments. And let's say ads, right? Ads as in video ads and image ads and all those things. So all these types of data can be served by test data service. There are different types of data as well. So these are some of the examples which we serve right now. So there are two types to access this service. One is a GraphQL API, and second is a front end application. So basically, you can test as a service, which is endgame, right? In our case, so endgame is coupled with our test data service, so that basically we serve all types of variants of test data to them. Let me give you examples, right? So let's say you are building a feature and ads, right? You need a user with different types of plans to test that particular feature. Let's say in Hotstar we have multiple types of plans, a super plan or a premium plan. In premium plan we don't show ads right now. So let's say you want to test this particular feature in both of these plans. You might need to go to multiple teams. You need to go to user team to get the user information. You need to go to subscription team to get the subscription info and couple them and then get these users and then test these particular features right now. So it's a very big collaborative effort, right? So basically we have eliminated all this. You come to this service and then ask for the particular user. Let's say you want a mobile user, ask for the mobile user. We'll give that particular mobile user which we have already generated as a prerequisite conditions, and then you'll be able to test your feature accordingly. And test data service is basically responsible for state maintenance also. So once you get the data, it's already state managed, so your automation test cases won't fail because of the state changes. And it will always be a single source of truth for golden test data, which is like multiple variants of test data, which you won't um, which you won't miss when you're writing your automation test cases because it's all automatically tied with the endgame itself. Next slide, please, Amit. So the user journey will become something like this after the test data integration and the endgame service. So basically, a developer will be writing the OpenAPI specs, and basically he'll be installing the mock server CLI and then generating the mocks based on the OpenAPI specs which he's written. And in the local, he'll be generating the mocks using the CLI, and then he'll be doing the local testing using the mock and proxy, and then he'll be testing his feature manually or using the unit test or using the automation test cases which he is writing in the local in isolation with using the mock server. And when he goes to the pipeline, basically test as a service will come into picture, and this will generate the test cases. And basically the plugin will be helping the developer to uh, run the test cases, and he has to add the deeper integration test cases as well. And for the scheduled nightly jobs, let's say some teams will be running regression jobs daily. Let's say in the morning, every morning your job has to run as a regression, and then the reports will be sent, right? So in order to schedule those jobs, basically uh, you have to schedule a pipeline. Let's say in GoCD or in Jenkins, you can schedule this pipeline, and then you can integrate these test as a service into with the test data service, so that you won't miss any type of variance of test data. So that you won't get any bugs into the production system. Next slide, please. Yeah, so this will be the revamped developer workflow. Since Amit showed you the current developer workflow, you might be having multiple repositories. So in this revamped developer workflow, it will be one repo only because you're automatically generating the test cases inside the development repo itself using the OpenAPI spec. So basically, you developer will be writing the features, and then he'll be writing the test cases, and test engineers or developers itself write the automation test cases within the same repo, and then they'll be raising one PR at a time. So there won't be multiple PRs. Let's say for one feature, it's gonna be development code plus your automation test cases within the single PR. So the reviewer, the code reviewer, whoever is doing the review, can basically correlate the test cases which had been written with the development code itself, so you won't miss any test cases in the review process. So once that is done, the development code to development PR branch has been merged. You're executing your unit test cases in the pipeline, and you'll be executing your automated test cases using the pipeline using the endgame service. Once that is done, you'll be proceeding for release. So let's say you have one more layer where the third-party integrations will come. Let's say you are building a subscription service. There, your third-party integrations will mostly be like Razorpay or Paytm or some third-party service where you have your integration, your contracts being served with the third-party service. So in that case, you go to a pre-production or a staging environment where you test your integration testing, meaning your third-party contracts, and then you go to your production system with the help of all these endgame services. Next slide, please. Yeah. So So what's the impact and what's the case study? So basically, impact is like, as Amit told you, right? There are four types of problems, four problems which we have identified. So all these four problems comes as impacted. So basically, we have reduced the time to release software. Why? How we have reduced it? We have reduced it based on auto generation of the mocks and tests. So in the local, once you write the OpenAPI specs, mocks and tests are auto generated using the tool itself. So people don't have to write the boilerplate code to generate the framework, generate the utilities and all those things every single time. So whenever a new service comes up, this framework, NDM framework will kick in and automatically generates the mocks and tests for you. And it reduces the setup time because there are no multiple repos. It's a single repo, basically the service repo itself, and you just have to set up one repo at a time for a service. And we are achieving standardization in the using the single framework, right? We are so all the microservices within Hotstar follow this particular framework. So all the utilities have been spread across, and nobody misses nothing. All the good things goes to everyone, and all the golden test data can also be consumed because of the test data service integration. And we get stable environment and no test flakiness. Let's say we are testing in isolation, right? So there won't be any downstream service dependency, so no test flakiness. And you can also test multiple varieties of data and multiple varieties of conditions. So let's say your microservice is dependent on a downstream service, and you want to test the latency of the downstream service. Let's say you want to test a circuit breaker which you have written for a downstream service. So in order to test that, you need to cross a latency to hit the circuit breaker, right? So in that case, you can simulate that environment in a mock server, and then you can basically test that scenario. Or if you want, let's say your downstream service hits you with a 500 or a 400. So basically, you can test all these kinds of test cases using the mock server. And earlier in the old framework, it is not possible because of the dependency with the existing services, and you won't be able to do that. And improved contract management. So basically, API contracts are managed using the OpenAPI spec, and it's been shared with all the stakeholders, right? Service owners and service consumers. So there is that will be the single place where your contracts are being managed, and contract testing is being done before the implementation itself. Let's say your client is building on the OpenAPI spec, and basically service owner and service consumer both would have agreed upon it, so that the integration would be smoothless and it won't have any friction unless there is a change in the middle of it. Even if that is the case, the contracts will be automatically be communicated with the respective stakeholders. So let's go to this case study. So what we had done is, like, we had done this case study using a test engineer. So we have tasked him with two different frameworks, but same set of steps we have given them. So basically, this is like you have to create a contract. Ask him to create a resource file. Ask him to write the step definitions for that file, and run using that particular pipeline. So he had taken around using the traditional Cucumber framework, which you are using in the teams. Basically, it took around 6 hours for him, and basically he covered all the success scenarios and negative scenarios. He couldn't able to cover it properly. He had covered few of them, but he couldn't able to cover all of these because of the downstream service dependencies. And in the second case, where we had shared the tool to him and then basically asked him to generate the test using the OpenAPI spec in that particular tool, he basically generated the whole test scenarios which we had given in around 30 minutes. So this is basically a reduction of time in around 5 and a half hours. So just because all the tests have been generated using our tool, and basically few updates have to be done by his side for the deeper integration test cases, and all the templates, meaning utilities, test data, and then mock server client, everything is basically pre-baked, so he don't have to waste time on all of this and then write the boilerplate code for him. So that's it from my side. Like, we'll take questions post this slide. Thank you for it.
Yeah. So we have one question over here. Are we doing unit testing here, or component testing, or contract testing? No, unit testing is not part of this framework. Unit testing is still a part, like in the source code itself. We have the test resource files, and where we do the unit testing. This is more about integration testing, contract testing, and the component testing. So if you have a REST API, we test those REST API with different variations of test data.